Okay, so we're going to talk about inverse trig functions. And so for any kind of function, just a regular kind of function, to have an inverse, it has to be a one-to-one function. So it must be one-to-one, which means there's one x for each y and one y for each x. It also means that it passes the horizontal line test and the vertical line test if it's a one-to-one function. So if we go to the sine curve, and we check to see if it's one-to-one. Is it one-to-one? Does it pass the horizontal line test? No. So this horizontal line right here would cross lots and lots and lots of places. So it fails. So what somebody did a long time ago is they figured out that you can restrict the domain to make it one-to-one. So let's talk about what this person did. And we did when we were doing inverses, we would also restrict the domain. So we would cut off part of it. And so what the person did back in the day, I don't know when or who, they decided they would just use this part of the sine curve. So just darken it with your pencil. It should be pretty light on your page. So they only used the x's from negative pi to pi. Sorry, I said that wrong. Negative pi over 2 to pi over 2 for the restricted domain. That way we can have an inverse. What's the range? Negative 1 to 1, yes. Okay, so over here in this little grid, we're going to graph the inverse sine of x. Or the arc sine of x. They mean the same thing. They both mean the inverse trig function of x. And I'm just showing you this to show you why it works the way it works. I'm not going to have you guys graph an inverse sine function, so don't worry about that. This is just, I thought if I showed you why it is the way it is, it would help you remember it. I'm not really sure if it's helping today or not, but we're trying. All right. So do you guys remember whenever we had inverses, like the relationships between their domain and ranges? Like if this was the domain and range of the original function, what the domain and ranges of the inverse function? They would switch. Go ahead. So if the range of the sine was negative 1 to 1, then the domain of the inverse is going to be negative 1 to 1. Same thing for the domain. So if the domain of the original was negative pi over 2 to pi over 2, that's going to be the range of our inverse. Okay, so I'm just going to have this little graph. And for my x-axis, I'm just going to go from negative 1 to 1, just like the domain, sorry. And the y-axis, I'm going to go negative pi over 2 to pi over 2. All right, and then for if you have the original graph, which we're just talking about this portion of it, and we want to graph the inverse, the x and the y coordinates switch. And so what it ends up looking like, it has an end point here and here, and it ends up looking like this. It doesn't continue in either direction. It just stops right there. Okay. So what we put in, what we put into the inverse sine function has to be a number between negative 1 and 1. And what you get out is an angle between negative pi over 2 and pi over 2. All right. So the inverse sine always gives an angle between negative pi over 2 and pi over 2. So let's think about what quadrant that is. So 0 is here, pi over 2 is here. But normally, like when we go around labeling, we don't label negative pi over 2, but where would that be?
Miss Skipper?
Yes, ma'am.
We need Ashton Farrell for checkout, please.
Okay, he's on his way.
Thank you.
You're welcome. So where would negative pi over 2 be? Right here? Yes. So it's where 3 pi over 2 is normally. So this is the positive rotation. This is the negative rotation. Those are the angles we're looking for. So there are going to be angles that are either in quadrant 1 or quadrant 4. So when we're doing with our function is the inverse sine, so sine of the negative 1 of something or arc sine of something, we are not going to give any angles over here. It's not going to happen. Don't do it. Don't do it. Don't use these sides for inverse sine or arc sine. Just quadrants 1 and 4. And even an angle that's normally in quadrant 4, like 11 pi over 6. Is 11 pi over 6 between negative pi over 2 and pi over 2? No, so we are not going to give that either. And the reason why is because of how we did the domain. Okay, let's do another one. So cosine is different. It still does not pass the horizontal line test. So we're going to restrict the domain from 0 to pi. That section of cosine does pass the horizontal line test. Right? And the range is the same as it was on sine, negative 1 to 1. All right, so over here, we're going to graph the inverse cosine or the arc cosine of x. They mean the exact same thing. Our book doesn't really use arc cosine and arc sine. I don't know why, but you might see it. Okay, and so we can use the restricted domain and range of cosine to get our domain and range of inverse of cosine. All right, so what we put in to inverse cosine has to be a number between negative 1 and 1. What we get out is going to be an angle between 0 and pi. Right? Now we're used to those angles. All right, so what comes out of cosine is either going to be a normal angle in quadrant 1 or quadrant 2. All right, so let me go back and do this graph. Now, since we cannot get a negative y, I'm just going to draw my x-axis at the bottom. At x, we're going to go from negative 1 to 1. Range, we're going to go from 0 to pi. All right. And so this graph is going to have endpoints at the opposite corners from the other one. It's going to cross in the middle, so it's going to look like that. All right, we got one more, and then we'll start doing some problems. All right, so for tangents, we're going to restrict the domain for just this portion of the tangent because it would also fail the horizontal line tests. Now, we're actually not going to include negative pi over 2 and pi over 2 because the tangent is undefined there, so we'll just use parentheses to not include it. All right, what about the range? Yes, negative infinity to infinity because it keeps going up and it keeps going down. So we're just talking about that one little section to restrict it to so it can have an inverse. Oops. All right, and then we can use those to find our domain and range of the inverse tangent. Okay. So where tangent of x had vertical asymptotes, what do you think the inverse tangent should have? Horizontal asymptotes. All right, and then it's going to be a shape. Oh, let me try that again. Kind of like that. Okay, and so the range on the inverse tangent is the same as the range on the inverse sine. So I'm just going to rewrite this whole same thing that we did earlier because it is the exact same for the tangent or the inverse tangent. All right, so taking the inverse tangent gives you an angle between negative pi over 2 and pi over 2. All right. So we're in that same situation. So there's quadrants 1 and 4. All right. Now, again, I just showed you all that. So hoping that it would make sense to you when we actually use the trig functions. I'll be flipping back and forth, so hopefully you'll remember. Okay. Oh, you guys if you don't have the hand trick like permanently in your brain, you might want to get that paper out, or we can draw it. I'm not very good at drawing a hand. That's not terrible. All right, so if I was going to label this hand with the angles, what's the pinky angle? Pinky is 0. It's okay. And then as we go up? Yes. Yes. Okay. And then if I wanted to find the sine of an angle using the hand trick, what would I do? Yes, square root of the bottom over 2. Whoops. What about the cosine? Yes. And then what about the tangent? Nice. All right. So when I go to do A, it's the inverse sine of 1/2. So you did the hand trick and you got 1/2, and you need to figure out what angle you did the hand trick with. And so what is this 1? Bottom, square root of 1. So that means there's 1 bottom finger. All right, so then we're going to figure out which angle that is that has 1 bottom finger, pi over 6. Now, since it was a positive fraction, that means this is going to come from quadrant 1, and pi over 6 is in quadrant 1, so that's the answer.
Why couldn't it be quadrant 2?
Well, I'm glad you asked. Because whenever your problem says the inverse sine or the arc sine, it's talking about this situation where you only use angles between negative pi over 2 and pi over 2. So if we picked one like, what would it be, like 5 pi over 6, it's not in the range of the inverse sine. So whenever it's a function, like these are representing functions, you can only get one answer. And so the answer is either, for sine, the answer is either going to come out of quadrant 1 or quadrant 4. I know it's different than what we did on Friday. That's what it's making this a little more confusing, because the way it's just presented to you can cause it to have different answers. Okay, so on B, we're going to do the inverse cosine of negative square root of 2 over 2. So for the inverse cosine, our angles have to be between 0 and pi. So in quadrants 1 or 2 only. So if this is a negative square root of 2 over 2, which quadrant do you think it will be? 2. Even though we all know there are other quadrants where it's negative, for this specific way that it's written, we can only give one answer. Okay, so for cosine, the square root of 2 on the numerator means we want 2 top fingers. Okay, so which angle is that? Pi over 4, but we want pi over 4 in quadrant 2, 3 pi over 4. All right, it's about to get a little weirder. Sorry. All right, so on C, we want the inverse tangent of negative square root of 3 over 3. This is going to be weirder for a couple of reasons. So for tangent, inverse tangent, we have to give angles between negative pi over 2 and pi over 2. So quadrants 1 and 4. So for this one, which quadrant do you think it's going to be? For negative square root of 3? Quadrant 4.
Why?
Because the tangent of an angle in quadrant 4 is negative. And the tangent of an angle in quadrant 1 is positive. So if we're taking the tangent of an angle and we get negative square root of 3 over 3, is going to be somewhere where the tangent is negative, which is quadrant 4. There's a lot of words. It takes a while for this to sink in. But because it says inverse tangent, you see this symbol right here? There can only be one answer. And that one answer is either going to come from quadrant 1 or quadrant 4. We are not using these quadrants. So if it's the inverse tangent of a negative, it has to be quadrant 4. If it's the inverse tangent of a positive, it has to be quadrant 1. Okay. So if we do the tangent rule, which is square root of the bottom over square root of the top, for this one, we need 3 bottom fingers and 9 top fingers. And so nobody's hand looks like that. So we have to rewrite it. So we kind of have to unsimplify it. So what do you simplify to get that? 1 over the square root of 3. So that means I want 1 bottom finger and I want 3 top fingers. it's going to be the pi over 6 finger. But we want pi over 6 in quadrant 4. But we want the angle to be between negative pi over 2 and pi over 2. It's a whole lot of buts in one statement. So really, all you have to do, if it is a pi over 6 finger and it's the inverse tangent, it's just going to be negative pi over 6. I know. All right, we're going to do one more of those, and we're going to move on. Something that might be slightly more difficult. All right, we're going to finish with the easier stuff today. I know it's weird. Okay, so for inverse sine, we are looking for an angle that has this sign. And that angle can only be in quadrant 1 or 4. So which one? 4, because it's a negative, yes. All right. And then for sine, it's the square root of the bottom over 2. So I want 3 bottom fingers. What do y'all think? Pi over 3. And so for it to fit our situation, what do you think? I think someone said it. I was talking. Negative pi over 3. That's it. Okay. I think I planned too much for one day. It's going to be okay though. All right. So now let's look at A and B on example 2. A and B are different than C and D. So if you guys came across a problem like this where you have parentheses inside the problem, where would you start? Would you start on the outside or the inside? We start on the inside. So we're going to start with the cosine of 11 pi over 6. And whatever we get for that, we'll put inside those parentheses. Okay? Which finger do I use for 11 pi over 6? Pi over 6 finger, right? All right. For cosine, what do I do? Yes, pi over 6 finger. And then it's going to be square root of the top over 2. What quadrant is 11 pi over 6 in? Quadrant 4. Is cosine positive or negative in quadrant 4? Positive. And so what do you guys think this should be? Yes. All right, there's a second part to this problem where we have to think another way. All right, so now we're thinking what angle, our answer to inverse sine is the angle. What angle has this sign? More specifically, what angle in quadrant 1 or 4 have that sign? So for sine, what does the 3 mean? Bottom fingers. So what angle? Yes. I know. It's a lot. It's a lot for your brain. We can do it though. Okay, so right now I want you guys just to ignore the inverse cosine and just use what we did on Friday to find the sine of 5 pi over 4. Right. Did you guys get a positive or a negative for the sine of 5 pi over 4? What should you get? Positive or negative? Negative? Whoops.
Is there any way, like, to remember which quadrant, which like quadrant those are in, or do you just have to memorize?
Well, I'm gonna have you guys, like, when we do this more, I'm gonna have, those things we drew where this was pi over 4 and then this was 3 pi over 4 and this was 5 pi over 4. I'm gonna have you guys draw that over and over and over again, so you'll either memorize it or you'll remember how to draw it. So it's in quadrant 3. Is sine positive or negative in quadrant 3? Negative. So it's negative, and then use the pi over 4 finger, so it's square root of 2 over 2. You're right. That was all Friday. Okay, now we're talking about today. So now we're trying to find an angle between 0 and pi that has a cosine of negative square root of 2 over 2. So that means that there are two top fingers. And what quadrant would it be in? Our choices are 1 or 2. 2. Okay. So two top fingers is going to be pi over 4. What's pi over 4 in quadrant 2? I just drew it. 3 pi over 4. All right. Now, I do understand that's a lot to remember. It's okay. Yes, sir.
So the other were 1 and 4.
Yes.
And now it's 1 and 2.
There are 3 totally different functions, so they all have different ways that you do it. So yes, you have to keep it straight. I know it's a lot. So if you look at what we wrote on the front, did you write this?
Yes, I wrote everything down.
Okay, so inverse sine is going to be quadrant 1 and 4. Inverse tangent, quadrant 1 and 4. Inverse cosine is different. It's quadrant 1 and 2. Why do we not use 1 and 4 for cosine? Like, why does it have to be different? Cosine's positive in quadrant 4. So you have to have one quadrant where it is positive and one where it's negative. So we couldn't do 1 and 4 for cosine. It has to be different. Okay, these we're going to draw triangles. It's going to be easy. Ready? Okay, so for this one, we have the cosine of the inverse sine of 4 over 5. This inverse sine of 4 over 5 is just an angle that has a sine of 4/5. So we're going to draw that angle. Here is that angle. So if the sine of this angle is 4/5, what do we know about the triangle? The opposite is 4. The hypotenuse is 5. What's the adjacent? 3. All right. So the inverse sine of 4 over 5 is just this theta. So I'm going to just rewrite this as cosine of theta. Because that is what it is. All right, and then look at your triangle. What is the cosine of theta?
3 over 5.
Boom. Sit. Got it. All right, so on D, it's not as obvious the missing side, but we can find it. So this time we're finding the sine of the inverse tangent of 7/4. So the inverse tangent of 7/4 is just an angle that has a tangent that is 7/4. So the opposite is 7. The adjacent is 4. What's the hypotenuse? Yes, we're doing the Pythagorean theorem, and we are adding 7 squared plus 4 squared, and then taking the square root. I did several steps in one. I hope y'all are okay. We've done Pythagorean theorem enough. I think you got this. If not, I don't know. Let's do. Okay, so this right here is just the angle that has that tangent, and that angle is theta. So I just replaced it with theta. So now we're going to do the sine of theta. So that's the opposite over the hypotenuse. And I don't think that on the ACT they might leave it like that. I don't know if this is on the ACT. But we would want to simplify it for our challenge exam. All right, are y'all okay? Ish? No? Okay, we're going to do one more. 2 more, actually. On the challenge exam in the past, this is what they put on there. So out of everything that we've done today, these 2 are the most important. And they're not really much more difficult than the ones we just did. So we want to find the cosine of the inverse sine of x over 3. So this inverse sine of x over 3 means it's an angle that has a sine of x over 3. So opposite is x, hypotenuse is 3. Which is kind of weird, but it's not terrible. All right, so then when we find the missing side, are we going to add or subtract with the Pythagorean theorem? Subtract, so we'll call it b. So b squared is equal to 3 squared minus x squared, or 9 minus x squared. So b is the square root of 9 minus x squared. That cannot be simplified. I know you want to. Take the square root and then subtract them. You cannot do it. That's all you can do. All right. So the inverse sine of x over 3 is just this angle theta. So I can replace it just with theta. So what's the cosine of theta? Yes, ma'am. That's it. It's kind of a complicated problem. It doesn't require as much thinking as some of the others, though. Okay, we're going to do one more. All right, so we're going to draw the angle that has a tangent of 2x. So I'm going to make the opposite 2x. I'm going to make the adjacent 1. So this time, when we find the missing side, are we going to add or subtract? We're going to add. This one is slightly more difficult to simplify, but it's the same concepts. So the inverse tangent of 2x is that angle theta. So if I want to find the sine of that angle, I'm going to do the opposite over the hypotenuse, which leaves a radical on the bottom. So you would want to simplify it. It's going to look really weird. But that is the most simplified version of the answer. Okay, so now look over everything we did today and ask me a question that you might have. Every period, there's been lots of questions here. So if you have one, don't feel weird about it because everybody has one. It's okay.
Don't feel weird about asking questions. I just don't know what to ask.
Oh. Well, I don't know how to help you. That's the situation. What most people have been confused about is the quadrants, like where you get the answers on like the top Example 1 and example 2A and B. I honestly don't know how else to say it. So if you are ever like, I don't know where this is going to come from, just flip over on the front and look at what we wrote here and here. And hopefully it will make sense to you. But they're all different. Like, it's going to take a while for it to all sink in.
I hope.
Yes.
So on like C and D on that example 1,
Mm-hmm.
whenever you just did negative,
Yes.
conversation negative parentheses.
Mm-hmm.
So whenever you're going like around the quadrants, or depending on like whichever finger.
Yeah. Mm-hmm.
And you get one that's not within the range of that of tangent, sine, or cosine, when you're doing, you just go the negative way, like.
Maybe. So on inverse tangent, I just don't want to say always.
Yeah.
Because the way you worded it, but I think you're good. So if it's inverse tangent or inverse sine, you just do the negative of whatever angle it is on your finger. For inverse cosine, it's not going to be negative. It's going to be the normal angle we're used to in quadrant 2. So what you said was if you find it and it's not in the range, you can just do the negative. I think that's right.
Okay.
But just know, inverse cosine, you're never going to do the negative. All right. Any other questions? Okay. I'm going to give you your assignment. I am actually going to give you a couple of days to do it before it's late. I want you to do some of it because tomorrow we're going to practice this some more. If you haven't practiced it at all, it's going to be tough on you. But on page 429, I want you to do 2 through 12 even, 19 through 24, and then 27 through 30. And if you have it done tomorrow, I'll give you a stamp, but I'll also give you a stamp for it on Wednesday because I really want you to do it. I don't want you to be like, this is too hard, I'm just going to forget it. I just won't get that stamp. I want you to do it.